Okay, the GME example has gotten to the point where I can write to the APU DSP registers from the main STL application. And I want to summarize the modifications I've made to make that happen. One of the first things that I've done is I've created an SPC DSP register map interface class. Long name, but I don't know an alternative name for that. So in the SPC emu, which is like the higher level class out of all of the SNES related classes in GME, the SPC emu is like the highest level one, and I have SPC emu inherit the DSP register map interface. And let's take a look at the DSP register map interface. I think it's here. So this interface needs to have an SNES SPC type to work with because it uses its functions, being able to access the DSP. So it gets a little complicated as usual. See, originally I wanted to use the SPC emu class. As you can see, I have it up there commented. But for some reason I was having problems getting it to compile with that header file. It wasn't identifying the class SPC emu, the compiler. And since the SNES SPC essentially has the same functions, actually ultimately the SNES SPC write function, which is seen here, actually references the the SPC emu's write function. So it's a little bit backwards, but it was the only way I could get it to compile. So there's that, and then like one of the higher level classes that's above all of the like emulator specific stuff is the music emu. I don't think I do anything with that. And then even higher level is the music player class, and that's where I do stuff. So in the music player class, I've added an SPC emu pointer type, ultimately just so that I don't have to continually cast this into an SPC emu. I can just do it once, and I have to do it at the right time. So I do that in the load file method. I go ahead and I cast the emu, which got loaded in the call before it right here. So I cast it to an SPC emu pointer, and then I can use that. The only thing is that this is private, right? First of all, there needs to be an underscore. This is a little outdated. So there's the underscore. Anyway, since it's private, I have a public accessor method right here, which will return the private dude. And that's pretty much everything as far as adding this DSP functionality. We could take a closer look at the map interface class that I wrote. Basically, for every DSP register you want to write to, you need to write the address of the DSP register into F2 and then the value in F3. So I wrote this little helpful function to take care of that automatically. And then just helpful functions in English, like write voice 0 volume left. You can just use this English function with whatever value you want. It would be helpful to add in some logic here to cap the values at the proper range, because it'd be bad if you fed it like a value from outside the range. For instance, I think the volume will only go up to 128, so if you gave it like higher volumes, there should be some logic somewhere that enforces those boundary rules. But it just goes on to provide this functionality for voice 0 through voice 7. And these functions include the left and the right volume, the low and high byte of the pitch value, which ultimately this should be an even higher level function that will write like a pitch from an 88 key keyboard. Like you can write C4 or D5, E sharp 3, I mean F. But so that, and then this I think references the sample SRCN. I don't know, I forget. And then the ADSR, the address, decay, sustain, release envelopes, gain, all this fun stuff. It can all be referenced from the DSP register map page on the SNES dev manual. Okay. And then, nope, I'm not done yet. In the player.cpp is where I actually access all this stuff from the highest level. So the highest level class is the music player, which is player in this top level source file. And the way to access the DSP registers from it is after the regular initialization is done, which has nothing to do with me, that was part of the example. The load file method gets called inside music player, which will initialize the SPC emu pointer. So then all you end up having to do is use this player SPC emu, and then we can access anything really that's a part of SPC emu. But with the addition of the inherited DSP register map class, yeah, we can access these functions. So that's how it's done right now. I'm not sure if it's like completely 100% sensical, but that's how it's done right now. So then you can just use those API calls. Right now there's only the API for writing to the DSP registers, but there should be, bless you. Let me take a look. There should be, first of all, there should be something to write to any value in SPC memory. I mean any address, which I think can be leveraged from, let's see, what was it? SNES CPU class? No. DSP register map. SPC emu. Yeah, I was saying earlier how there was problems if I would put the word this in there and then try to have this reference in SPC emu. So I used the SNES CPU, which is a variable in SPC emu, which is called APU. So I send the address over there. There's the inheritance going on from SPC emu. But yeah, since you have this reference to SPC emu, I think I made these functions public. They were originally private, but now you can use these to read or write any address in the SPC RAM space. That's good. And then I made a video of an example where in player I just added some simple logic to, well, let's take a look at it. I adjust a noise DSP register, which takes 20 hex, like a range of 20 hex, 0 to 20 hex, to adjust the pitch of the noise channel. So I have this automatically sweeping the whole range of the noise pitches every 10 milliseconds. And as that's getting sweeped, there is some logic like further below that allows you to, like, if you want to take a look at that, you can pause the video, go back. But the logic is further down here, which this is really not up pitch, it's just old comment. But what this does is it will increment this old variable called pitch high, which is really a noise on variable at this point. But that's what happens when you rapidly prototype with whatever variable is available to you. but basically every single frame I just continually write that noise on variable to the write noise on API command. And I have an example, so I'm just going to go to that example. So check this out. I'm going to do it to the classic song. Check it out. So I'm turning it on again. That's on channel 1. Let's put them on channel 1 and 2. That's just channel 2. Channel 1 and 2 right there. Alright. Whoa. Alright, so yeah, that's an example.